Section 34 of The Science History of the Universe, Volume 1. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Marianne. The Science History of the Universe, Volume 1, edited by Francis Rolt-Wheeler. Astronomy, Chapter 23, Variable and Binary Stars, Part 1. After the various stars in the heavens were classified according to their brightness or magnitude, it became apparent that there were striking and important variations in their brilliancy. When Hipparchus compared his lists and catalogues of the brightest stars in the sky with those of earlier observers, he was duly convinced of the occurrence of changes in their position and brightness. This was strikingly emphasized during his own lifetime when, as we have seen, a bright star flashed up in the constellation of Scorpion and then slowly faded away. Such changes as this in part induced Hipparchus and other ancient astronomers to make their star catalogues, for it was realized by them that there were from time to time new stars and a large number of variable stars which, while but a small part of the host of stellar bodies, nevertheless existed in considerable number. Unlike other astronomical phenomena, these variations in stars cannot always be predicted. In many instances they obey no rules, and especially in the case of new stars, or novae, they blaze up in sudden glory, remaining bright, and then perchance fading swiftly away in darkness. For convenience these variable stars have been classified into groups, all containing prominent examples and differing considerably from one another. These classes may be summarized as follows. 1. New stars or novae, consisting of a few stars that appear suddenly, like the star in the constellation Scorpion discovered by Hipparchus. 2. Variable stars of long period, fluctuating in light by large amounts during periods of several months. 3. Stars whose variations are small and irregular. 4. Variable stars of short period. And 5. The so-called algol variables, which are usually of full brightness and at regular intervals grow faint owing to the interposition of a dark companion between the star and the Earth. Variable stars have long been known, but only about 250 were recognized by astronomers until photography and spectroscopy were applied to their discovery. 3 remarkable discoveries, Professor W. H. Pickering of Harvard College University states, are responsible for greatly increasing the number. The first was by Mrs. Fleming at Harvard College Observatory, who, in studying the photographs of the Henry Draper Memorial, found that the stars of the third type in which the hydrogen lines are bright are variables of long period. From this property she has discovered 128 new variables and has also shown how they may be classified from their spectra. The differences between the first, second and third types of spectra are not so great as those between the spectra of different variables of long period. The second discovery is that of Professor Bailey, who found that certain globular clusters contained large numbers of variable stars of short period. He has discovered 509 new variables, 396 of them in 4 clusters. The third discovery, made by Professor Wolf of Heidelberg, that variables occur in large nebulae, has led to the disclosure of 65 variables. By similar work, Miss Leavitt of Harvard has found 295 new variable. The total number of variable stars discovered by photography during the last 15 years is probably 5 times the entire number found visually up to the present time. Hundreds of thousands of photometric measures will be required to determine the light curves, periods, and laws regulating the changes these objects undergo. The discovery of novae, or new, temporary stars, the first class mentioned, continued from the time of Hipparchus to the invention of the telescope. 4 new, or temporary, stars were discovered in the interval between the catalogue of this ancient astronomer and the beginning of the 16th century. The star of Bethlehem may have been of this character. In November 1572 a brilliant new star appeared suddenly in the constellation of Cassiopeia, which was observed by Tycho Brahe during the 16 months of its life. During this time it rivaled Venus at its brightest, and revived Tycho's interest in astronomy, which at the time was beginning to wane. He wrote at considerable length a description of the star, published in 1573, and Kepler subsequently remarked that if that star did nothing else, at least it announced and produced a great astronomer. In modern times the most striking nova was a star which was discovered in Perseus in 1901 by the Rev. Dr. Anderson, of Edinburgh, an amateur, who in 1892 had discovered a nova in the constellation Auriga. "In the sudden appearance of Nova Persei," suggests Arrhenius, "we evidently witnessed the magnificent termination by collision of the independent existence of two heavenly bodies." Typical of the second class of variable stars, which exhibit marked irregularities in period and in brightness similar to those of the new stars, is Eta in Argus, which in 1677 was classed as a star of the fourth magnitude, and in 1687 and 1751 of the second, and in 1827 of the first magnitude. Then Herschel found that it fluctuated between the first and second magnitudes. In 1837 it increased rapidly in brilliance, and in 1838 so far outshone the typical first magnitude stars that its magnitude was denoted by 0.2. But in the following year it declined to the first magnitude, and there remained until 1843, when it rapidly brightened until it outshone every star except Sirius, magnitude -1.7. Thereafter it slowly declined to the sixth magnitude, and since 1869 has fluctuated between the sixth and seventh. These observed changes point to a great collision in 1743 and a smaller one in 1838. The smaller collision may be compared to the fall of the Earth into the Sun, which would develop heat sufficient to maintain solar radiation during 100 years. From the older observations it appears probable that the star suffered at least one earlier collision. Another star of this type is Mira, or Omicron Ceti, which was the first star to be recognised as a variable, having been discovered August 13, 1596, by David Fabricius and described minutely by a Dutch astronomer, Phocylides Holwarda (1618 1651) in 1639. In 1667 its period of about 11 months was fixed by Ishmael Boulad or Bouladus (1605 1694), although it was found that its fluctuations varied considerably. It was described in 1780 by Herschel, who had observed it in 1779 when it was nearly as bright as Aldebaran. 4 days later the star was invisible even through his telescope. The maximum brightness of this star varies from the first to the fifth magnitude. At the minimum it falls below the sixth magnitude, becoming invisible to the naked eye, and occasionally below the ninth, so that at its maximum it has 1,000 times the luminosity of its minimum appearance. The spectrum of the star indicates that it is surrounded by three nebulous envelopes. The innermost of the surrounding envelopes is uniformly distributed, and the others form a ring with 2 points of maximum density corresponding with the traces of two eruptive streams. This ring revolves in 22 months and has a linear velocity or rotational period of 14.6 miles per second. Hence it follows that the diameter of the ring is 1.4 times that of the Earth's orbit, and that the mass of the central stars is slightly less than that of the Sun. Mira Ceti is typical of most of the variable stars in that they are red and give continuous spectra crossed by dark bands and bright hydrogen lines. The third class of variable stars comprise those of irregular period, which differ from the so-called new stars in that they recur at more or less regular intervals of a number of years. These are for the most part red stars, although there are others that fade away and are even lost from telescopic vision, though once seen with the unaided eye. In some cases they have been associated with faint nebulosities. Typical of the fourth class of variables is the star Beta Lyrae. Stars of this class have a short period measured by hours and days, and their variability is considered due to eclipses by darker companions, though both are self-luminous. As they have a white or yellow color, dust rings in their neighborhood are believed to play an important part in their phenomena, though less so than in the rays of the red star Mira. As typical of the fifth class, composed of variables that change with almost absolute regularity, Algol or Beta Persei may be cited. This star's variability was first noted by Geminiano Montanari (1632 1687) in 1669, but it was more than a century later, in 1783, when John Goodricke (1764 1786), a deaf and dumb astronomer, detected the regularity of these changes and fixed their period at very nearly 2 days, 20 hours, 49 minutes. Algol at its minimum luminosity gives about 1/4 as much light as when brightest, and the change from the first state to the second is effected in about 10 hours. The Algol type of stars, including about 25 variables, are white in color and are characterized by a short period, which in most cases is less than 5 days. The change in intensity of light was first accounted for by Professor E. C. Pickering as due to a second or dark star which travels about its primary, eclipsing it at various times. As the dark star begins to eclipse the brighter, the light diminishes until the time of greatest obscuration is reached, after which the normal value is attained. Pickering's theory for Algol, which normally is a star of the second magnitude, was demonstrated to be true by Vogel at the Potsdam Observatory in 1889. Therefore it is two stars, or a spectroscopic binary. Galileo and subsequent observers noticed that in many instances stars which appeared to the naked eye as single really were double. When these stars were separated under a high magnifying power, it was found that they varied in distance, magnitude and color. Thus if two stars are almost in the same line of sight, they will appear to the observer to be very closely related, although one of the pair may be much nearer to him than the other, and their proximity merely accidental. Such a pair of stars is known as a double star, or as an optical double, and is to be distinguished from a pair of stars at approximately the same distance from the Earth, but so affiliated that they revolve around a common center of gravity. In other words, their relative positions would resemble those of the Moon and the Earth. When thus paired, the combination is termed a binary system. The discovery of binary stars was first made by Sir William Herschel. He discovered that there were changes in the relative positions of the two stars, which obviously were not connected with the motion of the Earth, but indicated an actual circling movement of the bodies themselves under a mutual attraction. He found that there was a regular progressive change in their motion, which indicated that one of the stars was slowly describing a regular orbit around the other. Indeed, it seemed that gravitation had its effect beyond the solar system, as the orbit of each of such a pair of stars was found to be an ellipse, with a common center of gravity at the focus. That is, the stars were moving in two ellipses which were precisely similar, except that the one described by the smaller star was larger than the other in inverse proportion to the star's mass. While Herschel was the first to actually see such binary stars, yet their existence had been deemed probable by the Rev. John Michell, who lived a short time before the great observer. Not only are there double stars to the number of 10,000, but triple and quadruple stars, and even multiple stars in a single system. The distances between these stars generally amounts to from 30 seconds to 1/4 second, as double stars nearer than the latter figure can be separated by only the most powerful telescopes. But the spectroscope enables stars much closer together to be resolved, and in fact the important class known as spectroscopic binaries, previously referred to, can be studied and their physical and optical properties determined by elaborate measurements. Thus Polaris, which in a moderate sized telescope appears as a double star, including one of less than the second and one of less than the ninth magnitude, is really quite complex, for the brighter star revealed by the spectroscope has three stars very close together and all in circulation about one another. Again, in the case of binaries a spectrum with two sets of lines can be seen in the spectroscope. With the telescope the image is single, but nothing can explain the double's spectrum except the existence of two separate bodies. Accordingly, connected pairs of stars such as these are known as spectroscopic binaries. Often they make up a system of double stars visible in the telescope. Such an example would be Mizar in the handle of the plough, which, seen with a small telescope, appears as a double star, one of its components being white and the other greenish. In reality these two stars are situated so distant from each other that from one of them the other would appear merely as an ordinary bright star. But the telescope shows that the brighter of these stars is again a binary system of two huge suns, revolving around each other in a period of about 20 days. End of section 34.